Okay, so this is a weird resolution because it's both of my monitors, so you can see exactly what I'm doing. Oh my gosh, wait. I put them perfectly side down. Is it even streaming? Oh, it is. Connect you and code. Okay.
True for area, collision shape, static body, character body, camera, raycast, audio stream player, and so on. Most of the properties on these nodes are pretty similar, and other nodes like timer and animation player don't even have a 3D equivalent. They just work the exact same way as in 2D. And this actually applies to programming as well. Detecting if a raycast 3D is hitting something is done using the isColliding function, just like in 2D. And as
Ooh.
usual, you can move a node 3D by modifying the position. Of course, positions now have a third component that can be modified, the z-axis, but otherwise the procedure is the same. And then the bad news. The bad news is that while Godot tries its best to ease this transition, the world of 3D graphics is vast and complicated. While 2D games work by drawing sprites, in other words, flat images onto the screen, 3D games combine a lot of different asset data, such as meshes, textures,
Huh?
character rigs, and animations, with the
Yeah.
in-engine rendering
You
tools
can.
such as shaders,
For
lighting,
context.
particle
Okay,
simulation.
wait. For context, by the way, guys. No, I know that's not the context. The con. You know those like. You know those. I'm not. Dog. I biologically cannot produce children.
You're lying.
What do you mean I'm lying? It's biologically proven.
You're a lemon, so you have to be lying.
Valid?
Lemon? What? That game's so skibbity toilet alpha sigma. Can I eat your children?
Okay, so you know those like pills that come with like the sponge dinosaurs? That's what he was talking. That's what he was talking about. I didn't have.
I'm SpongeBob.
Is this entire stream just gonna be you rage baiting me?
No.
And post-processing effects. The pipeline for this can quickly become pretty complicated, and it's definitely an area where I see a lot of misunderstandings. But fear not, this video should clear up a lot of your
Please stop. I'm
confusion
trying
and
to
teach you
actually
how you
feel.
can approach this with as much complexity as you'd like. Creating aesthetically pleasing 3D scenes doesn't have to be rocket science, and we can often rely on the ease of use of Godot
Can you not? I'm trying to actually learn stuff.
to help us out. I've split this video up into two sections. First, we'll look at functionality, how we can design and prototype 3D games in Godot. Then, we'll dive into graphics.
You used to call me on your cell phone. Tonight I'm gonna be mine.
Ah, there it is. Milanote.
I want to spill water on your face, but I won't.
Okay.
I'm taking your headphones.
No, dude, stop! I'm legitimate.
Okay, I'm sorry.
It's okay. I told you not to rage bait me, and you freaking rage baited.
Bye.
Bye. Okay, we're in Milanote now.
I left my phone in
Okay, grab your phone, bro.
I missed you, so I'm just gonna stay in here.
Okay, can you like keep it?
Oh, Mr. Water, filter.
Clean it up.
Okay, Mr. 6'7".
6'7", 6'7", 6'7", 6'7", 6'7", 6'7". Okay.
What goes on the internet stays on the internet.
Unless I private the video. Okay. So style. Use this template.
I successfully juiced your children.
Can you not freaking? I told you not to interrupt me. Key feature. Fast paste movement. To do. Player. Build a map. Okay. I don't know. I just need a break from this. Project budget. We don't need. We don't need a project budget. Right? Okay. Yeah, I know it's been VR. Okay. Okay. Hey. Okay.
Hello and welcome back to the channel. Today we'll be making a complete first-person character controller from scratch with a bunch of features to enhance the game feel, also known as game juice. These features will include head bob, inertia, and movement FOV change. So let's dive right in. We're going to create a new 3D scene and call it world. For our ground, we're going to use a node called CSG box, which is basically a simple mesh combined with a collision shape that's good for prototyping. Our character is going to use a node called character body 3D. We're going to add a
Okay.
mesh to it by choosing the bean shape in the mesh dropdown. We're going to create a collision shape from the mesh by going to this menu and selecting create simplified convex collision sibling. If we turn off the visibility on the mesh, we can see that we end
Dog, we can just do a capsule shape.
Up with this disheveled bean that has less vertices than the original, which is good for performance. Let's add a script to our bean. Character bodies get a default code template with movement and jumps implemented, which works well for both first person and third.
Wait, so if I literally just do that, will it work? Okay. The thing is, like, I've been using Unity for the longest time because, like, that's literally what I started with. Okay, select current. I just realized we don't have a camera, bro. Camera 3D. I'm honestly, genuinely, like, curious if anyone has made, like, G-Tech mode. Okay. Project setting. Okay. W A S T. Okay. Now we have our. Let's see what I can edit here. So that seems to be jump. So I'm just gonna do jump A B blah. Okay, and I think I can just what? Not right now.
Person controllers in order to imitate do is if we don't have one and try to rotate the camera, we get some very janky results. If you're curious as to why this also able to move around our code, we have the speed and jump velocity constants here. The gravity it's set the velocity so we're going up, and then every tick we lower this velocity if we are not on the floor until the velocity is in the negative and we are going down. Depending on we're about to land stays at 0 because we are now on the floor and are no longer changing it. This last code block takes care of movement on the floor.
Yeah, I understand how
It
this
tells
works.
if it's not on the code, all of the action, and then see what. First step then is to get rid of the cursor. We can do that in a ready function which runs at the beginning of it and the kept in on ready variables, and if
Oh my god. cam. This should be easy, I guess. Hippity hoppity. Your code is now my property. Darn you. Okay. So I just gotta do boom, 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 boom. Okay. Oh wait.
If we use the unhandled input files, we are rotating, which we're going to rotation order mass. You'll also notice this is our rotation work pointing the maximum moving in the direction that we're facing. This is an easy fix in the code. Right now, when we set the direction of our movement, we are setting it to where the character body is facing. Instead, we need to set it to where the head is facing, since that's the
Or you could just like do what I did. Cause like I know how it works. I know the math. Cause like I can explain it to you right now. So this checks if you're moving your mouse. Then it takes the mouse's X and then times it by the mouse sensitivity, which you just guessed, because I'm gonna guess it's gonna be very high. And then it clamps it to like actual good degrees. Cause like I know how this works. Like I know how the logic works. I just don't know how to put it into code yet. You know? Okay. So I gotta do func ready. And then input dot set underscore mouse underscore mode. Okay. No description available. Okay, let's just see if this. Why can't I? Can't I exit, bro?
component that's looking left and right for us. Nice. Now let's juice this game up. The first thing that we're going to add is head bob that will help us imitate the character's footsteps by moving the camera up and down. Maybe something like this. Can you guess which mathematical function we can
Sine wave.
use? That's right. The function of my emotional well-being.
What?
While I was waiting for Godot 4 to release. I can't breathe here. Or the lesser known sine wave. To implement this, we are going to need a couple of variables and constants. First is bob frequency, which will affect how often our footsteps happen.
Okay. Huh. Godot. Okay. Bean. On.
Imitate now the hammer handing off of X smooth also known as and the rotation axis Y as the byproduct handing of how translating mouse movement to camera rotation works. When we move the mouse left and right, we want to rotate around the Y axis, which is pointing up, and when we move the mouse up and down, we want to rotate around the X axis, which is pointing to the side. So after putting all of this together, we can finally look around. Our sensitivity might be a little too high, and also we can do cartwheels with our head. So let's use the clamp function, which can limit the rotation of our camera to a minimum and a maximum value. I'm also getting tired of staring at a white floor with nothing on it, so let's use a bunch more CSG boxes with different color materials to create a map.
Okay. I guess I just do 50 by 50. Oh my gosh, wait, is it only? Oh my gosh, I know the freaking problem. I put the freaking move and slide inside of this. You're supposed to be. You're supposed to be in there. There we go, bro. Forgot to enable collision on that. Also, it's like, it loads really fast. Unity takes frickin' forever, bro. Okay. 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 So, I'm gonna try and make a material. Ooh. Resource. Let's see. Do I like. Oh, vertex color uses albedo, I guess? Okay, I'm a bit intimidated by this. Because how do I change the colors? Like, oh. I'm just stupid. I'm just stupid. That's the problem. Trying to get like a nice red. It's just. There we go, bro. Can I get a nicer red? There we go. That's a red. Okay. I didn't position them low enough. Okay, I think I'm gonna attempt to use scripting without a, I mean, not scripting, sprinting without a tutorial. Okay, so go here, sprint. Okay. So I'm gonna do, okay. If direction. What do you mean if direction? How do you, what, what is if direction? What do I, what? Okay. Um, Okay. Oh, wait. How does it... Okay, I need
Much
a
better. The
tutorial.
last thing we need to fix with the basic movement is the fact that we're not really moving in the direction that we're facing, right, for us. Nice. Now let's juice this game up. The first thing that we're going to add is head bob that will help us imitate the characters. First is bob frequency, which will affect how often our footsteps happen. Second, bob amplitude, which will affect how far up and down variable that we will pass to the sine function that will determine how far along the sine wave we are at any given moment. We're going to increment this variable during every tick of the physics process by multiplying a couple of things that affect our head bob. First, we want to account for delta, or how much time has passed since last tick. We will multiply this by the speed of our character since we want to head bob more often when we're running. And finally, we want to make sure that we're only bobbing when we're on the floor and walking rather than jumping or falling. So we will multiply the result by the is on floor function, which converted to a float will either return 1 or 0. We can then assign the position of the camera to the result of the head bob function that we will pass the t-bob variable. 2. Let's code this function real quick. It will return a vector 3 variable that we are setting the camera position to within the physics process. Initially, this vector 3 is going to be a 0 vector, but we are going to assign its y-coordinate to the sine of t-bob times bob frequency, and then multiply that by the bob amplitude. So now instead of going from -1 to 1 like sine, we'll go from negative amplitude to amplitude. The result is a pretty good head bob, but if you're looking for a bit more realism, we can also add a horizontal component to this since our head is also moving left and right when we're walking. This time we're going to assign the position x component to the cosine of time, or t-bob, times bob frequency divided by 2. Still keeping up? Multiply this by bob amplitude as well. I think this will look way better for a lot of games. Now let's add sprinting to make sure that our bob looks good at different player speeds. To do that, we'll change what we set our character velocity to in this code block. Since we now want our speed to depend on whether we pressed shift or not, it has to be a variable. So let's create a speed variable and change our speed constant name to walk speed, as well as create a new constant called sprint speed. Back in the physics process, we will run a check on whether the player has pressed shift or not, and then set our speed variable to either sprint speed or walk speed.
Yeah, okay. What I was confused was just this. Because, like, I'm not doing, like, the extra stuff because I'm just bored. If input dot is action pressed, and I just do sprint, then speed equals, I don't know, 15, else speed equals 5. Okay. Now we just need, okay, wait, actually you don't need that. Okay. 75 to 90. Okay. Okay.
Here is a quick tutorial on how to use linear and I'm going to press the arrow go to P, do this whole process. Go ahead and put it in the middle. Any other mistakes we move, release enter key. Intended to use basically like kind of the rate that we have to by our variable up here is just ought to be different. We want vector. It's a change to the
equals loop from velocity to vector to wait, no. You have to loop from 75 to 90.
New value without it.
And I just gotta loop from 5 to 15 at a rate of 1. Loop from 15 to 5 at the rate of 1. Loop from 90 to 5. Okay. That's still like... Why can't I? Okay.
Without any kind of hesitation or gradual easing. Whereas if
Okay.
we do anything less than 1, it will be more gradual. The smaller the number, the more gradual.
Oh my god. This is why you watch the entire video before doing code. Because then you're just gonna learn that you have to... Why? He's gonna say something. And it's just gonna be...
So if I did say 0.01, you'll see the difference in the effect as our kinematic body starts moving across the screen. So I'm hitting enter now. Nice gradual start. Pretty abrupt stop still. So whatever key is on it. And gradual slowdown. Well, maybe too gradual.
Okay.
Start. See what that looks like.
I'm honestly so confused. Because, like... Let me just try... Like... Freaking switching these. Why isn't it, like, looping? Do I need to do, like, the vector 2 thing? Where I put in 5 and then 0? Speed. What am I supposed to do? Yo, AC, I'm trying to, like,
Especially good for motion and rotation and scale, things like that.
dude, 5 minutes. I have to wait. I have to watch him say the app for 5 minutes before I freaking get. I am so confused on why this lit function do it.
We need to. By our variable up here is just automatically a vector already set is the rate we change to
Oh, it's vector 2 and then another vector
new
2.
value. If we do a 0.0
Okay, wait. So,
It by 2 would make our current velocity
dog, he just.
usually around partly this on the desired velocity using the air, we are instead going to interpolate towards the desired velocity using the lerp function, which changes our speed incrementally. This function takes three variables. In this case, it's our initial velocity, then our target velocity, and the final one is the decimal percentage of the distance between then our this the desired velocity using the lerp function, which changes our speed incrementally. This function takes three variables. In this case, it's our initial velocity, then our target velocity,
Okay.
and the final one is the decimal percentage of the distance.
Okay, so I just have to times this by delta. That seems simple. Okay, now it's still.
Distance between then our target velocity.
Okay.
Takes three variables using the lerp function, which changes our speed incrementally. This function takes three variables. In this case, it's our initial velocity, then our target velocity, and the final one is the decimal percentage of the distance between the two.
I'm going to freaking. Aha! What I don't get is why the FOV isn't. Oh, wait. this lib gonna work?
Variables that we want to cover in each step. Since our delta variable is usually toward button midair, we won't just stop right there. You can play around with this value to figure out 3. Another thing we can do is fix that running stop mechanic. Stop on characters variable multiply by our target f multiply that our f numbers clam v. After that of the value controller is complete the link to the GitHub project that we want to cover description, so you can start where I left off. I complete the link to the GitHub instance that we want to cover, and with that is the target value, and the third is the decimal percentage distance that we want to cover, and with that our character controller is complete.
Shh. This is probably the worst code I've ever. Does it even change? I'm going to frickin' log this. I'm gonna print the FOV. Print am.fov. Why? Why? What? Maybe I just have to do delta times 8, like the video does. Oh, so that's the magic number. Okay. Okay. Freaking swinging. Yeah, no, I'm not freaking making a Godot fan game, bro. I'm trying to make my own game.
user in for this project is down in the description.
No, I don't want 3D. Okay, wait. So I just need a canvas layer.
If you're using Godot and you want to figure out an easy way to create a pause menu, you can add the canvas layer node. Coupling the canvas layer node with some control nodes can help you create an easy pause or main menu system. Just always make sure to leave your control nodes as a child of the canvas layer. If you're using Godot and you want to figure out an easy way
Okay. Label settings. Label settings. Um. Velocity X. Velocity Y. Velocity Z. Okay. So I just needed that. Oh, wait. I can just do. That's easy. Boom. VX. VX. VXT. Oh, wait. It's already done. Okay. So, file y dot text equals string velocity dot x. Okay. Okay. Now I just gotta lift these. Oh. Oh my gosh, I freaking. Okay. Now I. Enough stalling.
User interface in 3D is
Here is a
Where do I even.
Hello and welcome back to the last tick. We will multiply this by the speed of our character to end this code block. Since we now want our speed to depend on whether we pressed shift or not, it has to be a variable. So let's create the wind in our horizontal movement when they are on the floor. When they are in the air, we are instead going to interpolate towards the desired variable is usually around 0.05. Multiplying it by 2 would make our current velocity move towards the target velocity by 10% each tick. Now when we let go of the movement button mid-air, we won't just stop right there. You can play around with this value to figure out how much control you want while you're airborne, but I eventually settled on delta times. In the character template, just ramp up a little how fast we come to a stop.
Okay. Okay. Speed delta times 7. And then we just replace this with loop.
Up here, and bam, inertia done. There's one last thing I want to do to juice this character controller up, and that's changing the camera field of view depending on character.
This code is getting like messy. Okay. Yeah, this is feeling like really nice.
Speed. For this, we're going to and set the FOV to our variable to this equation, which is base FOV. We will be setting a local target FOV variable to this equation, which is base FOV plus we'll set of characters. If the video was helpful, drop a like and let me know what you think.
I'm subscribing to that guy because, like,
Welcome everybody. In this tutorial I'm going to be teaching you how to create a sliding mechanic for your game, complete with some on-screen speed effects and some animations to move around the camera. Okay, so what we're going to want to do is come to our player scene here. And we want to add an animation player node so that we can start to animate. So frame for non-change set, a keyframe for translation, and just go through the settings in here. Turning off gravity, having effect jellies on system or place more so downwards, where it will be visible a bit because to create a reference and go here. Slide, it's use load speed and power, and here you can see it's release of the button.
I think I know how I'm gonna do this. I'll just like do a really long loop. Okay. 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 So that does work. Okay. Where am I going? Where are you taking me? Stop. What? I don't get it. What? Okay, wait. So if we're moving, then... Oh wait, but I do need the direction stuff. Is it this? Why was it that? Oh, it's because we're setting it to the speed. Okay. What I should be doing is that. Okay. I didn't mean to make that. What if I do two?
Reset or certain speed effect should power will have higher speed and will have all that and to normal, so that's whatever the original value was.
Okay, let's see. Oh, gee. You know what? Alert from from speed to 30, and it's gonna take 5. Okay. Okay. Now I gotta make the animation. Okay. So first, what I need to do is I need to take the Y position and I need to create that. And then at 1 second, I'm gonna move it down here and then I'm gonna create a keyframe. That is so like long. Okay. Okay. Why? Did you cheat on that game? Cause like I I'm just gonna say that right now that kind of hurts me. Cause like I put hours and hours into developing, modeling, scripting, doing all that crap, and then like kids that aren't even old enough to know what the Pythagorean theorem is and how to prove it are like just like download some random ass thing and then they just ruin the game. The game is like not even not alive right now because I'm just taking a break from it. Okay. Hmm. Okay. Ah, Perry the Platypus. Yeah, Perry the Platypus. Yo, honestly, like, okay, what I'm gonna do instead of this, I didn't really know how to, I don't know how to design an anti-cheat. And I don't, like, go onto those terrible script hub servers, because then I don't learn anything. Because, like, look, I literally cannot access any sort of, like, chat GPT or, like, Gemini or Claude. Like, I have it blocked. I blocked it for myself because I wanted to learn. And I did. I learned how to make inputs. I learned how to do this. Okay, I don't think this is how sliding. The thing is, I'm like, I'm kind of like sad. This is why I kind of quit game development for a bit, because I put all my care and everything into stuff. It's like, it's like making a, I don't know, spending all of your time on a painting, and then some kid comes over and then cuts it in half with scissors and then lights it on fire. And then everyone's like, this is so ugly. I don't want to look at this anymore. I'm leaving. And I'm like, and then I'm just sad because I couldn't really do anything about it because, I don't know. Hmm. So wait. Oh. I'm about to freaking crash out, Rotato.
And the jump power goes back to normal once we release it. With all that set up, the effect should be well. Now, if you did enjoy this video, that was just or something. But here I have bar speed. It's using the movement rotations. If you don't have a variable for speed on your player, it might not work for you, so you might have to change it a little bit. We're also my jump. It's far start with back end. The effect should goes back to normal once we release it. With all that said, we'll have higher jump power, we'll have higher speed, and we'll have the particles looking all nice on our screen. Now, if you did enjoy this video, make sure you leave a like, leave a comment if you want some suggestions on future videos. This video was actually suggested by one of my viewers, who I'll put
channel. Today we'll be making a complete first person. Welcome back to the channel. Today we'll be doing a Godot level design. Right click on the, let's check it out and side of the grave the fog creates. This might be a little bit too much, so hello and welcome back to the channel. Today we'll be doing a tutorial on shooting mechanics for an FPS game in Godot. We're going to cover gun animations, bullet movement, complex collision shapes with body parts, and weak points for our enemies, as well as dying animations and enemy despawning. This video is most useful when you already have a character controller, a map, and some enemies, all of which I cover in my other tutorials, but you don't need to have seen them to understand this one. So let's dive right in. The first step is finding a nice gun model that's already in a Godot supported format or converting it with Blender. Get it into the project files and right click, new inherited scene. Save this scene and drag it into our player. gun scene and click on the mesh. In the geometry section, there's a setting for cast shadow, and add 3 keyframes, one for starting in their original position, one for the gun going back, and one for coming back to their original position. We only need to change the position on the middle keyframe, which gives us the whole animation. Now that we have it, it's time to get input from the player. Go into the project settings input map and create a new shoot action. Then bind it to the left mouse button. In the player script, create a new onReady variable for the gun animation player. Then in the physics process, we're going to check if the player pressed the left mouse button. If the shoot button is pressed, we want to check if the shoot animation is not playing. If it's not, we're going to play the shoot animation because we either just pressed the button or the animation already finished and we should shoot again. This looks pretty funny without any actual bullets, so let's add those. Go back to our gun scene and add a raycast 3D. Set its direction to -Z1 since that's the forward direction in Godot coordinates. Drag it towards the barrel and we have our bullet spawn. We're doing this to make sure that our gun model is facing in the right direction because it might have been made with a different coordinate system in mind. If it was, make sure to rotate the gun towards where the raycast is facing. Next, create a new scene for the bullet with a node 3D as the root. Save it and add a mesh instance as a child of the bullet. We're going to make this a box mesh and change the Y and X dimensions of the box to 0.05. Then in the surface material override, go ahead and create a new material for the mesh. We're going to add a new albedo color as well as an emission color for the bullet. Set the emission strength to 5 and that's how our bullets will look. Now add a raycast for collisions and just like with the barrel, set its direction to the -Z axis. We will set its length so it's slightly outside the mesh. Let's add a script to the bullet and the first thing we'll need is a speed constant. Set this to 40 and we'll also create onReady variables for the mesh and the raycast since we'll need them later anyway. In the process function, we will move our bullet by multiplying our rotation basis, or where the bullet is facing, by our velocity, or a vector 3 with the length speed facing in the -Z axis, which is again the forward direction in Godot. Multiply that by delta, and the movement is done. In the player script, let's start spawning the bullets. First, we'll need the barrel raycast from the gun, so let's make an onReady variable for that. We'll also need to load the bullet scene in a new variable, and also create a variable to hold individual bullet instances before we add them to the map. In the physics process, after we play the shoot animation, we will assign the instance variable to the bullet instantiate function to create a new object out of the bullet scene that we loaded. Then we're going to set the position of this new bullet to the global position of the gun barrel raycast, and set its transform basis or rotation to the global rotation.
Hey there! Let me show you how you can make a grappling rope in Godot for like this one. For starters, I'll be using my own character controller I worked on in the last 2 videos. It is based on the character controller body 3D node, so it is using forces to move the player. With that in mind, the grapple mechanic is quite simple to implement, since all it does is to move the player in the direction of where the hook is attached to. How can we figure out the hook location in the first person? For starters, let's add a raycast to the center of our camera. And in Reddit function, we update the person. For starters, let's add a raycast to the center of our camera. And in Reddit
Okay.
function, we update the max distance for this raycast. the axis you apply the constant to will depend on your scene setup. In my case, the negative z-axis is the forward direction of the player. By calling scene setup. In my case, the negative z-axis is the forward.
You know what? I don't even need this message since. There we go.
Direction of the player. By calling the getCollider function of our raycast, we can figure out whether it collided with something. If it
Okay.
did, we can use getCollisionPoint functions. Axis is you apply the how out the will depend on your scene in the getCollider function of a point function to get the position as a vector 3. We will also need a player position, and for that all we need is to access the position property of node 3D. Once we have the two most important values, we can use them to generate real-time mesh for the rope. For this, let's add a mesh instance 3D child to our main player node. Next up, for this, let's add the most important values. We can use all we need is to access the position out the forward direction. Since we can figure out since with that in mind, character controller body 3D node, so it is using an elastic to move the player. With that in mind, the grapple mechanic is quite simple to implement, since all it does is to move the player in the direction of where the head is attached to. And in ready function, we update the max distance for this case negative. We can figure out whether it collided with something. If it did, we can use getCollisionPoint function to get the position as a vector 3. We will also need a player position, and for that all we need is to access the position property of node. 3D. Once we have the two most important values, we can use them to generate all the points of motion to update velocity to apply a bit of gravity to the relation. After we move those points, we now need to constrain them so that they don't their position so that it moves in a direction that will make their distance from the previous point closer to the ideal distance. Ideal distance being 1/n of rope. Next up is converting the point into a mesh. In case of Godot, we need to use immediate mesh approach for real time, whether you're going to make a mesh from lines or triangles, which will, once you're done, you need to call surface properly. Even though the goal is to make a 3D cylindrical shape for the rope. For now, let's simplify it. In other words, like this. Code for Godot, here it is, since that video uses different coding language. Now we almost have everything we need to get our mesh. The code I will show to right
Dog, I just want...
manual is taken. Present sides of triangle, or in other words, sine over cosine. Anyhow, how much from an index array that will UVs in the next video, the surface, relay integration, the max distance for this raycast. The axis you attach to. How can, since all it does is to move the
Okay, you know what? I'm just gonna do... grappling equals false. What's this? Grappling equals true. Otherwise, grappling equals false. Oh.
player in the direction of where the hook is attached to. How can we figure out the hook location in the first person? For starters, let's add a raycast to the center of our camera, and in ready function, we update the max distance for this raycast. The axis you apply the constant to will depend on your scene setup. In my case, the negative z-axis is the forward direction of the player. By calling the getCollider function of our raycast, we can figure out whether it collided with something. If it did, we can use getCollisionPoint function to get the position as a vector 3. We will also need a player position, and for that all we need is to access the position property of node 3D. Once we have the two most important values, we can use them to generate real-time mesh for the rope. For this, let's add a mesh instance 3D child to our main player node. Next up, you have to set the top level property of node 3D to true, so that it ignores the parent transform. This is a crucial step, otherwise we wouldn't be able to rotate our player, since it would also affect the mesh.
Okay.
Now let's go over rope generation script. Before I continue, I'd like Hey there! In the last video I showed you how to make a grapple gun in Godot, but I didn't go into UV mapping, so let's take a look at that in this one. The code I'll be using is from that specific video.
Okay. I don't even know why I'm doing that. Thank you. So just do that. Okay. Okay. If I just go into my player, can I just add it? Can I just like go like this, do add child now, and then do line? Huh. I'm curious. Godot. Wait. What? You can just do that? You just have like a random model. You can do that. You can just like I can go do skeleton 3D, right? And you're telling me what? That's a thing? I don't know how to use.
Just for efficiency's sake, though, if you wanted to do this in a final and attacking an idol for 2 heal. So let's just go ahead and repeat.
Sorry, I just drag this in here. Open an editor. New inherited. What? Wait, and then I can. Oh my god. I can do that? Okay, here's the real question. Uh. Okay. So he needs the physical bone simulated, but how do I... So wait, I just... Kaboom.
Collisions aren't set up properly, then you would go into like the fingers. For any changes to the bone transforms that you need to change on both sides, just duplicate the change node and then set the bone name to the opposite. For any collisions that don't align properly, you will need to go through and correct them. The jolt physics is not here parameter if you only wanted a selected amount of bones to ragdoll. Here you can see the first test and it does not look good. This is because Godot's physics engine is not great with physics. So instead we are going to download Jolt physics engine. To do this, head to the asset library and search Jolt and download the one with the tornado icon. It will then prompt you to save and restart. Once you've done that, head to the project settings and in the physics tab should be one called 3D and then set the engine to Jolt.
Huh.
After testing it again, it's looking much library. So instead, we can create an array of
Okay. What? I'm disappointed, bro. Supposed to be physical, not just standing here.
bones as a parameter if you only wanted a selected amount of bones to ragdoll. Here you can see the first test and it does not look good. Instead we searched Jolt and done the engine exists. Select 6 looks much better. For the root bone, I named the spine to white and see it's a bit more realistic. You'll notice the zombie can fall through the floor. The only way I know how to fix this is by setting the physics tick from 60 to 90. Thank you so much for
Goodbye,
watching and I hope this video
Swats.
helped you out.
I made a game where you play as a ragdoll, fighting enemies with physics-based combat, but you start off really weak, barely able to stand up. As you struggle to take out the enemies, you gain strength. The character is made up of physics joints that kind of work like muscles, which means that as you get stronger, you can run faster, jump higher, lift heavy objects, and take out bigger and bigger enemies. But if you rush ahead before you're strong enough, it's not gonna go so well. The main
It auto played. Okay.
Multiplayer is a very daunting feature that all game developers will be plagued at one point or another, but it's not as hard as you think. Just use Godot. It has one of the